Greetings everyone. Today we're going to be talking about the differential equations. The differential equations. So we probably know that the derivative of a constant d over dx of a constant is always equal to 0. That means that if you have d over dx of 4 is a constant, you're gonna get what? You're gonna get a 0. If you have d over dx of a 10 raised to 1,000, for example, this is just gonna be nothing but a 0. So this is actually called a constant rule. Any derivative of a constant is actually a 0. So now let's talk about something that is called the basic power rule. The basic power rule. So according to the basic power rule, if you are given, for example, y is equal to x raised to n, this is the function that we are given, and then we know that n there is actually representing a constant while x is what? Is a variable. So if we want to derive that function there in terms of x, we're gonna have dy over dx, which is gonna be, we take that n, they will multiply it as a coefficient. That means we're gonna say n multiplied by x raised to n minus 1. So you multiply by that n and subtract 1 again from the what? From the exponent. So let's do another example. If we're given y is equal to x raised to a 17, when we're deriving that one, we can have dy over dx is actually equal to 17x raised to a 16, because we multiply by the 17, which is the exponent, and then we subtract 1 there from the exponent. That's all about the what? About the basic power rule. Then another thing that I wish us to talk about is actually the quotient and what? And the product rule. So in quotient and the product rule, it means that now if the function now is in terms of y, let's say for example is equal to f of x divided by a tree of x. Now what's gonna happen is that when you take the dy over dx, this means you're differentiating the function y with respective to x, you're going to get what? A tree of x multiplied by f prime of x, and then you say minus f of x multiply now by a 3 prime of x, and then all divided by 3 of x squared, 3 of x to the power 2. You square the denominator. So it simply says that if you are having the function over a function, this means that you are going actually to do what? To take the denominator, the function in the denominator as it is, and you multiply by the derivative of the function in the numerator, and you subtract. As for the second part, you take the function which you didn't derive, which is a tree of x, you derive it now, and then you multiply by what? By the function f of x, the function which you derived at first, now you multiply by it as it is. So you actually lastly square the numerator, the denominator, the function that was in the denominator. So let's take an example. If we are given y is equal to x squared divided by x, so how can we derive this according to what? According to the product, to the quotient rule. So according to quotient rule, now we're gonna have dy over dx is equal to, we said we take this function in the numerator, which is x, and then we multiply as it is by the derivative of what? Of the function in the numerator, which is gonna be 2x, and then we say minus. Now we take x squared as it is, but now we multiply by the derivation of the function which we did not derive at first, which is the derivative of x, which is simply a y. And then we're gonna have what here? We square the denominator, we get x squared. Then that means dy over dx is actually equal to nothing but multiplying this product, which is gonna be 2x squared minus an x squared, because x squared times 1 is an x squared, and then we derive by x squared, and then dy over dx is actually going to be 2x squared minus x squared is the same as 2x squared minus 1x squared, which is going to give us an x squared, and then divided by the x squared. This is going to give us nothing but a 1. So now let's try to prove if this is correct, because we were given actually a function y is equal to x squared divided by x, and we know that if we simplify this first according to the laws of exponents, we're actually having this the x to the 2 divided by the x to the 1. That means we have x squared minus 1, and then y is equal to x, because according to the exponent, to the rules of exponent, is that when you're deriving the functions of the same base, you simply subtract the exponent. So we know that x is always having an exponent of 1. Therefore we have 2 minus 1, and then the derivative of that function, which is dy over dx, we know that the derivative of x is equal to 1. So this gives us the same thing as we got when we were using a quotient rule. So the other thing that is very important is actually the product rule. So now how do we go about solving the questions in the product rule? So for product rule, let's say for example you are given a function y is equal to f of x multiplied by a tree of x. So what's gonna happen now here? You have two functions that are multiplying each other. That is why it is called a product rule. So that means now if you want to find the dy over dx, is actually you can take the f of x as it is, and then you multiply by the derivative of the second function, which is g prime of x, and then you say plus, and then now we take g of x as it is. We take g of x and then you multiply by the f prime of x. So that is what it means by a product rule. So the arrangements really doesn't matter, because the sign, there is not a subtraction, is always addition. So since here I started with f of x as it is multiplied by g prime of x, you can actually start by g prime of x multiplied by f prime of x, and so on. So this is what it means by the product rule. So this is all the basic information that you actually need to know. Thank you.